Hello and welcome to Graphcore. Today we have exciting news about the next stage in the evolution of AI computing, a major leap forward for Graphcore and our customers, made possible by some genuinely groundbreaking technology. AI is evolving rapidly, and the direction of travel is clear. The size, complexity, and capability of models is growing at an astonishing rate. Billions, even trillions of parameters are becoming the norm. Some have questioned how compute will keep up, but here at Graphcore, we want to accelerate the pace of innovation. So we're raising the bar once again with our most advanced AI compute system ever. Powered by a new IPU, our latest product family of IPU pod systems, named Bow pods, after the Bow area in London, deliver up to 40% more performance in real-world AI applications. Our new flagship Bow Pod 256 has over 89 petaflops of AI compute, compared to the previous generation with 64 petaflops. And we're adding Bow Pod 512 and Bow Pod 1024, delivering in excess of 350 petaflops of compute. This extra performance supercharges real-world workloads. So let's look at the results you get. Across the board, on a wide set of applications, from modern computer vision models like EfficientNet and vision transformers, to widely used natural language models like BERT and GPT, through to graph neural networks and more, we're seeing the benefits of that performance boost. It's unusual to get this close to the hardware's theoretical capability right out of the box. And we'll see further software refinements over time. Now let's look at how that scales across Graphcore systems, using the example of EfficientNet. Using a classic IPU Pod 16 as the baseline, we see the Bow performance advantage from Bow Pod 16 right up through Bow Pod 256. And Bow further widens the performance gap between Graphcore systems and the competition. Again, looking at EfficientNet, we see a 5x faster time to train on a Bow Pod 16 versus a DGX A100. When you factor in the difference in system price, the Graphcore TCO advantage is 10x. Just as important as delivering results faster, Bow pods are also more power efficient. On all the workloads tested, Bow delivers up to 16% better performance per watt, once again helping with the total cost of ownership. All of this on the hardware and software platforms that Graphcore customers have come to know and count on. The performance and reliability of our IPU machine blade, upgraded with 4 new Bow IPU processors and the same IPU pod architecture for extremely large systems. The low latency, high bandwidth communication enabled by Graphcore IPU Fabric, and the power and ease of use of our Poplar SDK. Everything our customers love about Graphcore systems remains the same, but with an amazing performance boost. How have we achieved this? Here's Graphcore's co-founder and CTO, Simon Knowles.
Our Bow pods are powered by a new member of our Colossus family of intelligence processors, or IPUs. We've retained the unique architecture that makes the IPU special. This chip has 1,472 independent processor cores, capable of running nearly 9,000 different programs at the same time, a true parallel processor. We have a massive 900 megabytes of ultra-high bandwidth memory on the same silicon die, giving the processor cores near instantaneous access to model parameters and activations. But the IPU in Bow is running 40% faster than its predecessor, delivering up to 40% more application throughput. This is achieved by harnessing a revolutionary new silicon integration technology. This is the first processor in the world to be manufactured using Wafer-on-Wafer stacking, or WoW for short. Partnering as TSMC's lead customer for this innovation in 3D chip technology, we've stacked the processor wafer with a second wafer, which adds a layer of deep trench capacitors right next to the processor cores. This enables much more efficient power delivery, allowing us to realize that 40% increase in compute, and at the same time to improve the IPU's energy efficiency. The Colossus Mark II IPU we launched in 2020 delivers 250 teraflops of AI compute, supercomputer performance on a chip. The new IPU in the WoW systems delivers 350 teraflops, the highest performance of any AI chip today. That's a remarkable gain thanks to our world-first use of Wafer-on-Wafer 3D silicon integration. But the innovation doesn't stop there. Our pioneering use of 3D silicon is helping to pave the way for something very special indeed.
Artificial intelligence is on a journey that very soon will see it pass a remarkable milestone. A human brain has around 100 billion neurons and at least 100 trillion synapses, which are equivalent to the learned model parameters in an artificial neural network. In just a few years, these numbers will be surpassed by advanced AIs. That won't necessarily give them human levels of cognition, but they'll be exponentially more capable than the machine intelligence we have today. It will take extraordinary machines to deliver this, and that's exactly what Graphcore is working on. I'm proud to announce that Graphcore is developing an ultra-intelligence machine that will deliver more than 10 exaflops of AI floating point compute. This isn't merely a vision. We're already working full steam on this project today. This machine will feature 4 petabytes of memory with a bandwidth of over 10 petabytes per second. This combined level of AI compute, capacity, and bandwidth will deliver an ultra-intelligence AI computer with model sizes that can exceed 500 trillion parameters. Wafer-on-Wafer and new memory fabric innovations will make this possible, and we're collaborating closely with several technology partners to bring this extraordinary computer to life. It was important that we give this machine a name, and we've chosen the Good Computer. Named in honor of Jack Good, a pioneer of early computing who worked alongside Alan Turing at Bletchley Park and later worked on a number of important machines, including the world's first stored program computer. It was Jack Good who over 50 years ago first described an ultra-intelligence machine, saying, "The survival of man depends on the early construction of an ultra-intelligence machine." At Graphcore, we're continuing the tradition of Jack Good, a tradition of relentless innovation that will give people the power to build a better world.